Hello. We are back. Quick update. Since last time, did a little bit of work offline. You can see in the description here, but I guess I'll just quickly go over. Did a pretty major reorganization of the files. There is now what used to be metagen main, which was like the platform independent start like main file that all of the platform specific ones called out to, is now just metagen, because in here not only is there the main, there is also the function that kind of does the overall work. This lex, parse, and run metaprograms. That all happens in here now. This used to be in codegen, and instead lexing, parsing, codegen, metaprograms, all that stuff are now services to this file, basically. So in that vein, we have the lexer still, that hasn't changed. Parser still, that hasn't changed. Codegen has changed, so this file got a lot smaller. It's pretty much just that one giant function now, which is the thing that takes a node and turns it into a string. As well as using that to spit out source files from a tree. That's what this file is. Pretty much all this file is all this file is for is turning nodes into strings, creating dependency maps of a tree, and spitting that out as a source file. And then I added another file called metaprogramming, which is all of the stuff that used to be in codegen, and it was like the post pass stuff. So, where's the post pass? Here it is. So it's like all the stuff that is technically meta programming, but is like integral to the language, basically. That happens in here now. So, this has its own file. And this is the thing that does the post pass and then kicks off the and houses the function that actually runs the metaprogram. So that all being said, this metaprogram util, which had all the stuff that was meant to be for writing your own metaprograms to help you with that, is now just all the stuff that even this metaprogramming file that does the base level stuff, it needs that stuff too. So it includes it at the top here. You always have access to the final program AST, so kind of the final say on the tree that you see printed when you ask for the tree. You always have access to that parser now. And then the output AST is just like it was before. It's the one that we're actively working on. So that changes as we go down the steps of the metaprogram. And finally, I took the cache out of the parser and just have a global cache now. That just kind of helps not have to keep track of the parser everywhere. So yeah, anyway. So where we're going tonight, whatever, is in the metaprogramming step. When we run these metaprograms, right now, what they're doing is I have this scratch lexer and this scratch parser that basically they are a full lexer and parser just like the main language is, but they are meant purely for metaprograms when they do their code gen. So like this thing that generates function templates, it generates source code, right? Most of your metaprograms that aren't doing tree manipulation, they generate source code. And when they want to add this back into the program, they use this scratch lexer and parser to do a full lex and parse of that generated source code. You're given a tree, and then that tree is stuck into your main program, which is fine. But as I've been doing some of this stuff, I've realized how messy it kind of makes the whole process to have to keep track of these things and have these floating around globally. When I realized all we really have to do, instead of like having these metaprograms spin this up every time they have code to generate, just have them stick their string of code onto a provided, like, the source file for that chunk, right? We already have these chunks, right? Just have it stick it onto the chunk file, and then all at once we can just parse the entire chunk file. And this does two things. Simplifies the system drastically, and gives us better error messages in metaprograms and the code generated from them, because we now have a single canonical source file that matches the line numbers as it goes, that you can then look at when you get an error in your generated code. So that's what I want to do now, and that kind of needs to happen before I go on to fix. So if you look, if I try to compile this right now and run this, we're currently broken because this util file is not up to date with the stuff that I've been doing yet. So, hey, dumb guy codes, how's it going? So for now, remember me? I do remember you. Just kind of gave an overview of basically what I have in the video description, kind of what we're doing right now. So, long story short, instead of metaprograms using this scratch lexer and parser, they're just going to append to a giant single source file, and we'll parse that all at once instead of spinning up this scratch parser every single time. So we're making that change right now. So instead of this output AST, we are going to have a, is it a metagen string builder? Yeah. We'll call this like current source builder, I guess. And we'll initialize that to 0. So, now when we call run metaprograms, the first thing we'll do is set current source builder, and I have to remember, do these hold on to an arena? They do. So this thing's arena will be the parser's arena, and that should be fine. So, okay. So for now, let's stop including this so we can see where things are failing. Wait a minute. Oh, right. Okay, we're not actually going to be able to test that yet. So let's say here we have our current builder. Can we reset these? So actually we want to call current source builder equals, we're going to say does that even have to be global? I don't think it does, because we can pass it, well, we'll make it global for now, so that way people writing metaprograms don't have to think about that. Create string builder. We're going to just pass it the parser's arena. And then so see, we're creating this source file chunk, and then we're calling run metaprograms internal on the chunk. I don't think we want to do that anymore. Instead, we want this to return right. So we have this output AST that's global, and then the metaprograms just do stuff to it. So I think instead, how do we want to structure this? So this is going to take the parser, obviously. It's going to take the AST that we're running the metaprograms on. That's fine. Instead of a node to output to, because I think, well, what does the parser give us, actually? The parser gives us, yeah. The parser actually gives us a source file node already. And the path is the Lexer's file path. So I think what we can do is have this return a source file node. An entire source file node. So this can instead take the file path. Let's see. I'm trying to think. Because it can set that right here. So it can take the primary chunk name. Or I guess the source path. It can take the path. So we'll say source path. And then that's fine, that's fine, that's fine. Okay. So don't care about this. That's fine. Okay, so here's where the error messages will get a lot better. So we can set the file path to this source path. And then that's fine. Reset the line number. Oh, but wait. No, we don't actually do any of this here. Actually. Anything that deals with the Lexer and stuff does not happen here. That's going to happen down here. Oh no. Forcoder is still doing that thing where it's not always copying. That's frustrating. Find where this goes. Okay. So no, this doesn't have to take the path at all. What this is going to take is, given an AST, it will give you back I guess the string, right? Metaprogram generate source from metaprograms. Okay, so given this, This needs to take the... It doesn't need to take the current source builder because that's global. So it does need to reset it though. So, is there any resetting these? I guess I'll just make that here. Reset or clear string builder. Builder strings is 0. Builder running line number is 0. Okay. So we're going to reset the scratch space, reset the source builder. And actually, we don't need to describe these. These are single lines. So clear string builder, current source builder. Okay. So, now the output AST is no longer a thing. Did we already remove that? We did. So, if we include the default metaprograms, it will take the input, scratch space. That's all fine. That doesn't have to change. Same with this. Great. So, here, we'll have a pointer to the final program. And why do we still want that? This pointer is the final output parser, and it contains the end-all be-all AST that ultimately generates final. Anything that wants a picture of the current state of the program can query this. And I guess it's because... Well, I don't actually know why. Oh, okay. See, this isn't going to be a thing anymore, I don't think. That will be. Because anything that modifies I do need to distinguish when metaprograms are modifying the main tree or not. Because if they're modifying the main tree, the cache needs to know that. And currently, I think plenty of them do. I mean, yeah, anytime... this is tricky because this is fixed if I only cache all at once. I just rebuild the cache every time. instead of doing it as we go. Which feels lazy, but it solves this problem. It also solves... It uncomplicates so many things in the future. Okay. That's... I don't love that, but... Instead of all these cache things, we'll just say rebuild node cache. And we will just... Does the parser still have an arena? It does, surely. Oh, but wait. Doing that is also not... Erg. The nice thing about doing it as we go is it plays nicely with our arena. We're never deleting... We'd be deleting a whole bunch of nodes every single time because we're just rebuilding the whole cache. Man. Unless, so... Alright, let's look at this and say... We have an input, an output, and a scratch. What are we using the scratch arena for right now? It's in metagen main. Scratch is being set to lex parse and run metaprograms, which is being set globally to scratch space. And scratch space is being used for quickly getting a node as a string. It's being used for space for metaprograms to use. Okay, that's fine. So, my idea here is, what if we have an additional arena that is the cache size? It's an arena just for the cache. Because then we can wipe that and start over, and we don't have to care about other people touching it. This is set aside for the cache. I think that's probably fine. I think that's probably fine. So arena. So we'll do another one here. And you know what? These are all the same thing. Let's have a quick helper for this, just to make me happy. Void we'll say initialize arena. Do they not already... Well, I guess they can't because... No. Because they don't have access to platform memory stuff. So, okay. Main, where were we? Here we are. Okay, initialize arena. Or allocate arena space. This is going to take the arena. That's going to take the size. These are U64s. Size. And it's going to take... That's it. That's all it takes. So we're going to say arena size. Okay. So now this can just be allocate arena space for the input arena. Move the arenas to the platform independent code. All we should do here is provide the chunk of memory for them. Oh. I see, okay. Yeah, that can come later, that's fine. 1, 2, 3, 4. So this is the output arena, scratch arena, and the cache arena. All right. This is output, this is scratch, and this is cache. Great. That just tickles my brain. That looks a little nicer. So, here's another case. We can clean up this interface to here, which I have it to do here. Hello, Aaron1206. Welcome. So, let's clear this up. So, metagen main, it'll take the path, that's fine. Let's create a metagen input data. It's going to take let's just put all this in it, shall we? Let's do the target source path, or output source path. And input data is like, that's fine. It will take a, let's make these flags. So metagen input flags. It'll be flag default metaprogram. Include, I guess. Whether you print the AST, whether you print stats, line numbers, okay. Flag print AST, verbose stats, and print line numbers. Okay. Okay. That's fine. So, this will be a single flags. And our arenas. I guess this is where I could actually give them the space, but whatever. Input arena. And actually, this can just copy them. These don't have to be pointers. Or do they? Yeah, we'll just keep them pointers. So you can just use them by name. Output, scratch, and cache. Okay. let me, I was gonna do some diagramming and stuff, but decided not to do that, so I can close all this stuff. Oh, crap. Sorry, one sec. I have all this stuff open that no longer needs to be open. Okay. So, where were we? Okay. Here's all our stuff. So now this function can get much simpler. I can just pass it the input data. Metagen input data. Data. And then this, I can have a single data, and this can be data input. So all these things can just be the pointers to these. This is fine. I don't think I have to care about that. And this can be data flags or equals flag print AST. This can be flags verbose stats. This can be okay, hold on. That should probably be append line numbers. I was unclear what that did. So that's fine. Flag append line numbers, and this is okay, this will be skip default metaprogram. That's fine. Skip default metaprogram. Okay. And this will be, we can drop all these. This can be data dot output source. No, what did I call it? Output source path. Okay. That seems fine. So all of this can just become the data. And do we pass that by pointer? We do not. We don't have to. Okay. Cool. Let's clean up the cache. So we data dot this. And then dot size is arrow size, dot base is arrow base. Okay. We good with that? I'm good with that. To do, well, yeah, well, we already returned the error, so that's fine. Okay. So here, we'll say short string target path is data source, output source path. That can be that. That can be that. Target path. Okay. This takes a pointer. That doesn't need a pointer anymore. This takes a pointer. As does this. As does that. Okay. And this... No. Okay. And then... flags are on the file. Platform. That's fine. Hey, diminished. I've been okay. Did a little work offline. Kind of gutted, or not gutted. I ripped apart this whole system and have been trying to put it back together in a way that makes more sense. So, just a lot of drudge work happening. But it's good. It's it'll be better for it in the end. So right now nothing works, but how about yourself? Have you been doing well? Okay, let's look at the data again. Okay. So that's all fine. So here we can pass this also the data. And you know what? Let's just pass the pointer. You know, why not just pass the pointer? And which means this is, oh, that's right, okay. Which means it doesn't need this. Cool. I think that's all fine. Print final output. Can also take the data. All right, this is cleaning this up a lot, which is nice. We'll go to print final output. This can just take data. So if data flags and flag print AST, we'll say B32 verbose stats is data and verbose stats. Did this do anything else? I don't think so. Oh, it took the arenas. I mean, I don't... Might as well post all of them. Yeah. Okay. So that looks good. Now we'll go to here. This thing can take pretty much just the data, the method, and the path. This can all just be the data, the method, and the path. Okay. Scratch space is data's scratch arena. And the method is already passed in. This is data input arena. This is source path is still fine. Okay. Source path, that's all fine. Output arena. Okay. That's all good. So include default metaprogram. This is instead going to be data flags. Actually, let's do this. Include default metaprogram is data flags and flag skip default metaprogram, and we're going to not it. So if they don't have this flag set, we will include the default metaprogram. I think that's it there. I think. Feels pretty good to me. So let's get back to where we were, which was in lex parse and run. We're going to go to the run metaprograms is where we're at. Okay. This is, okay, this is going to have to be rewritten. It's still mostly true, but this is still largely true, but doesn't reflect the fact that metaprograms primarily generate source code and no longer parse them and give back a tree. The parsing happens inside this function now. We'll do this. Is that a for-coder thing? To be like, hey, here's a break? I can't tell if that's a bug or not, but this comment, the below comment is still largely true. Okay. So, now we create the string builder. Our primary chunk is given. So we create a source file node, which we shouldn't have to do anymore. Generate source from metaprograms. So, our primary chunk, will now be a dynamic string, and it will be generate source from metaprograms. Take the parser. It will take the input tree, which is the parser's AST. Include default metaprogram is passed to me. Okay. First time is true. And this, I guess. Okay. So we don't need this anymore. Generate source from metaprograms. Does that not need... No, that doesn't need anything. That just gives us the source. So we don't need this either. Okay. Then, once we have that, so We already have all these lexers. I think we can just make another one here. I think. Yeah, I think we can. So let's just make one. Metagen lexer. Meta lexer is that. And then, well, actually, parse lexer. Technically, this should be a... Damn, okay. Lex parse and run metaprogram. Technically, this should be a linked list of lexers that we... I guess that's fine. We'll be calling this so I think that actually is fine. What did we do in the scratch case? Right here. See, we handed over the known types, which was annoying. We're still gonna have to do that. Which is really annoying. But that's kind of just the way this works. So I wonder if I wonder if I can collapse this into a single, like, do lex thing. And it will take the metagen lex method. It will take the data, and it will take the source path. And I guess it'll take known symbols. Or known types, rather. I mean, it has to take the lexers too. I don't know if I actually like this yet. We'll see where this goes. Okay. Otherwise, return 0, no error. No, return error. Okay. So this can just call do lex. It will take the data, the method, the source path, lexers, and known types. And actually, that happens here. We'll do that. And then this will be if error. If not error, we'll do this. And then we'll return it. Okay, that's fine. Lexing, parsing. So here, we can say man. Lexer, get new lexer. So where do we call get new lexer? We do that here, but does the lexer have the known types? It does. And we don't pass that down or up for some reason. For reasons I don't understand, which means it's probably an oversight. Arg Is there any reason oh man, this is hard to think about. The problem is I just need to run the lexer on this string. But lexers do I misunderstand this? Maybe I understand this. Or misunderstand this. Okay, maybe I misunderstand this. If I just do this, these are our meta lexers, right? And I call here, I call dolex on with data. And does it matter what method I use in this case? Metagen. That's fine. And then I give it a path, which in this case is source path. Oh, no, I have to make a new one of these. Lex. Dolex. This is what I want. I want Lex source code, is what I want. But I don't think I can just do that here because... Well, actually, I kind of can. You know what? There will be this dolex path, dolex code. This will be a dynamic string. Source code, lexers, known types, that's all fine. We don't need a method. Let's forget all this. We'll say U32 error equals lex source code. It's going to take the data input arena, get new lexers, I think. File path. And the source code. I think. Kind of losing my mind a little bit here. Okay. This will be dolex path. And this will be dolex code. The file path will be source path. The source code will be primary chunk. The lexers will be meta lexers. The type list. I need that to come from... Doesn't this need the known types from the... Wait, parser? That's on the parser? Oh. Okay. Sure. I guess. So we don't need that, or that, or any of that. Okay. So, we'll say U32 error is that if error, we'll say, do we have an error here? Yeah, we'll just say this. Well, if there was an error, it will say something. So, so we don't need this either. Okay, so do we use known types down here? You know what? Forget this. We'll just pass it the parsers, known types. Data, source path, primary chunk, meta lectures, known types. Okay. Then, once we do this, we do this, I guess. Do parse, recurse. Do parse of lexers. Oh, because we need the root directory. I'm gonna say we don't worry about that here. We can just grab all this and move it to here. So we'll pass it the parser, and we will say parser equals init parser. We're going to pass the data, which is this thing. We'll pass it a short string, source dir. We'll pass it the known types coming from the lexer, so that makes sense. This is when that gets connected. Okay. And we'll pass it the lexers. Okay. Do parse of lexer list. Okay. Okay, get node type string. Okay, that's fine. So, do parse of lexer list will happen here. Do parse of lexer list, and that returns. I don't know why this is a B32. We'll say results or error is 0. Get rid of that. If error is equal to that and it's not that, boom, boom. I can just return error. Or no, I can break. That's fine. We'll break and we'll just return error at the end. That's fine. So here, we'll do this yet again. Or, well, we already do that, so that's fine. Data, parser, I forgot a comma up here. Source dir that takes a dynamic string. Fuck it. Then lexers and known types. This is this, and this is this. Okay. There's a lot of nonsense happening here, but wait, where did the parser go? Oh, yes. So here we need a parser, and we pass it this. That's good. Okay. And then we return that parser at the very end. This should come out here though and be here. Whew. Still going to be unable to compile because there's a lot of this. Well, actually, let's do this. Let's get rid of this and just see where we're at. It's probably a lot of real bad stuff happening. Wait. Really? Okay. No return statement and function, clear string builder. Oops. This doesn't return a string builder. Let's do this. This just helps me see where my errors start. Look at that. Okay. Oops. Oh, because these are, I replaced the word output, and it replaced them there. Error was not declared. This is a U32. Wait, where was that not declared? 424. You are correct. Okay, we are down to one page of errors. Cannot convert that To an arena. Get new Lexer. Yep, that takes an arena. What do you know? Data. It takes this. $470. This cannot convert. Oh, it takes a pointer to a dynamic string. Okay. 484. Get node type string. Oh, duh. We do need this way. Get node type string, yeah. That's a little weird that we don't have both of those. Get node type string. Like, this should take a type, and then this should just call that, you know? No matching call for metagen lexer node type metagen parser node type. Actually, you know what? How about we make just this take U32s? Yeah. Post pass. Okay, we're back to where we were. Mostly. 649. Print line numbers. Right, we don't have that anymore because we have in the data B32 print line numbers is data flags and flag append line numbers. Whoop. What just happened? Okay. Output arena on 655. Yep, this is data output arena. And finally, those are not pointers. Okay. That's great. So I've successfully just done some cleanup there. Whew, okay, so now if we turn this back on, we will be back to failing a whole bunch of stuff in here, but that's fine, because now we are going back to here. So, after we lex the code, we need to do this stuff. So, we need to do parse of lexer list. And does that return an error? It does. I'm just not using it here. So error equals this. It's going to take the data. It's going to take the same parser. We'll use the same parser. Init parser. What is that doing with the known types? It's just copying them over. So if that's just copying them over, then this first time, okay, we collect the known types from all these lexers and pass it to our parser. So then it has all of them. So over here, what is that? Do parse of lexer. Okay, we don't want to init the parser here. We're reusing the same parser, right? So here, we do in fact want to say init parser, right? Yeah, okay. This comes down here. That makes it. This is where we had this before. So we init the parser down here. We give it the known types from the lexing that happened here. Okay. Then we call run metaprograms on that parser. And here we okay, so here we don't need, what is known types here? Do we even have a known types here? We don't. Right. This will be the same known types that the parser already had. Wait a minute. No, this doesn't need known types anymore. I thought that didn't sound right. That doesn't need known types anymore because the parser already knows its types. We only do that if we've lexed code and have to update the known types. So we do that here when we call init parser, and then with do lex code, what does collect known types do? Does that overwrite? No. So that's great. Man, okay, this doesn't deduplicate things. Add type to scene. It should. It should. So don't add types we've seen. For type index less than type list, num types, if type list types type index, if this one equals the type that we're doing right now, just end it. And we can early assert if there's not enough room. Okay, so that's fine. So we can just recall this. I'm okay with that. So this is great because now when we do this lexing of code from the metaprograms, and if we pass it this known types, that just keeps building. So when the parser parses the new source, it will have its known types. Like that'll be fine. It'll just carry that with it. We don't have to keep copying that over. So then we do a parse of these new lexers for the metaprograms, and now this should be there should be a single new node on the tree for this source file. Because Okay, we didn't actually finish writing this. This is going to return us the source. The result of running these metaprograms on this tree. So, over here, primary chunk, source. We will lex it. We will parse it, giving us well, giving us, I think, a single new source node, right? I think so. Because every lexer is for a source file, and the source file we're saying is just this big primary chunk file. So I think that's right. So, we will just say print ast of parser. Do I have like a get last child? I do. Get last child of parser. Okay. All this stuff for now. Let's just turn this off for just a second. Now this is still not going to work because there's a lot of work that has to be done on the util side of things. Like immediately, that's where these errors are coming from. Are there any that aren't in the util file? These are all... So there's one. Right, so there's one. Okay, they're not all in there. There's a few that are not, so... update node type, we're calling from metaprogramming 46. So, update node type, given an arena. This node has a new type. It needs the arena because it's creating a new node. That's fine. So this does take the arena. That's all good. Next, again, 75. Oh yeah, we do this in both places. Okay. Again, 872. We do it here in update function templates. And we do it again in here. Because the cache is global now, we don't care about the parser, we just need memory to do it in. So we just need the arena. 957, insert copy after 9. So these are where these functions are changing. So this needs the arena now because we don't just assume we have one. Yeah. Yes. Yes. Okay. Inserted. Once again, 1307. This needs an arena, which we have, thankfully. Okay, we're down to one page of non-util errors. So default metaprogram was not declared. 1572, what? To do build the string and return it. Default metaprogram. Default meta. Oh, did I not turn that back on? I did. Oh, I'm not including it. Right. So let's not tune these on yet because yeah, I don't know. We're not there yet. So do Lex code on 1638. Oh, do Lex code needs the data. That's fine. We can pass the data in here. Input data. That's fine with me. This is in meta. No, this is in, yeah. Yes. This takes the data. Okay. Declared void. Wait, what? Declared void. Wait, hold on, what? It doesn't know what this is? What? Oh, because that's include last. Okay. Do that. And you know what? We will call this main. Because that's just how we roll. Let's rename to metagen main.cpp because this is the main. And then metagen.h has the lexing method, input flag, that's all fine. Okay, that's fine. Do Lex code was not declared. Is that down here too? Yes. All this needs to move to actually, where does that need to move? You know what? There will be a metagen. .cpp. I really don't love this. I can take another crack at reorganizing this, but okay. Source stir wasn't declared. 1646. You are correct. This is source path. Wait. Oh. Oh. So init parser gives us a root. Do parse of lexer list. No, okay. That didn't need to be there anymore. That was a mistake. This doesn't need to be there. Because we do that when we call init, which means actually in main here, we don't pass this here. 1645. Lexers. These are meta lexers is what these are. Parser node. Wait, print AST of a node. Oh, get last child of parser AST. Duh. Finally, too many arguments to do parse of, wait. 1, 2, 3, it says 1, 2, 3. 1, 2, 3. Oh, I also don't have to pass it this. Oh, that's so much nicer. Those are nicer calls now. Okay, now we're back to everything being in the util. Well. Oh, these have to move to metagen as well. Which is actually, that's fine. All this can move to metagen, that's fine. Hello, Hurt Badly. Is this Hyperland? No, this is I3. I'm still on X11. This can go into metagen. I guess I can just go up here. That's fine with me. This is not Zig. This is, I wrote what started as a C++ parser in C. And I wrote it to do some metaprogramming stuff, but it then quickly evolved into me adding more stuff to it. So it is a basically custom language with some new things. Like there's this external keyword. There's these things called snippets. You can do basically like template stuff, only it's a little bit nicer and it's all powered by my metaprogramming stuff. Anyway, the parser is written in C. How did you get small? So this is not a terminal. Here's my terminal, right? This is just tmux. There's no smooth scrolling here. This is my editor. This is an editor called 4coder. That's the name of the editor. I just have my OS themed where things look the same theme. So this is my editor. The editor's the thing that's smoothly scrolling. Okay, did that fix those? Util. Yes, okay. All of our errors now are in util. I thought it was some Emacs plugin or NeoVim. Yeah, I used to. So actually, if I just type... So here's Emacs, right? And if I open one of these files... so here's... I can't make it bigger very easily right now, but here's Emacs. You can see it's pretty similar. This theme is actually out of date because the function names aren't colored correctly and stuff. But anyway, I used to use Emacs and then I switched to 4coder. And actually, I have a alias for terminal Emacs, so I can actually do that, and then the colors probably will be the same. No, still messed up here. But anyway. Are you based in the US? Yes, I'm from the Midwest. Okay. So, we're down to just errors in the util. Which is great. That's fantastic. It doesn't mean all this other stuff is working. There is likely horrible bugs in there, but we're not going to know until we fix the util functions. So, thoughts on prime intellect? I am learning HPC specifically for the kind of thing these folks did. I don't know if I know what prime intellect is. AI development at scale. Is this like a cloud provider for AI resources or something? They did reinforcement learning on a Chinese model on decentralized GPUs, Intellect 3. Okay. Yeah, I don't know much about it, so I can't really comment. Is there a specific plan with like what it will be used for and where it's going, or? I do admit I am out of the loop on a lot of that kind of stuff, so. Okay, util. Let's just start tackling these one by one. 607. There's no output AST anymore, which is correct. Actually, before we do that, let's get this going. So what this is going to do is it will return build string, and we're going to pass it the current source builder. Does that just return a dynamic string? It does. Okay. So this will get us our source code. We'll lex it, we'll parse it, and then we just want to print it at first. Oh, so you're not using all the terminal agents for coding? No open code, Claude code? No. Yeah, this is all from scratch, C, basically. I'm not even using any libraries. Like, if you look at, so like my Linux main, I'm just including like the system headers for the POSIX API. Yeah, this is all hobby stuff. But it's also kind of what my main kind of passion is, doing this stuff. So eventually if you look at my description, I've put out a game, so eventually this work will go into a new game engine, but also just kind of powering any kind of software stuff I want to make. So definitely hobby stuff, but it's also just kind of my focus on my creative outlets and stuff. Why not hobby programming in Rust? I just really like C. It's what I learned to do, and it's what I've been doing the longest. And now that I like how simple C is, mainly, and how it kind of stays out of your way. And now with this stuff, I'm parsing my own C-like language with a bunch of metaprogramming stuff in it. So going forward, I'll pretty much just be using that once this is in a good state. So, okay. So I think that's all fine. Let's go to 607. Add node to program. This no longer takes this. Oh, okay. We are not going to be doing any of this stuff anymore. No more adding nodes in the way we were. I'm just about to get started. I mostly code in Julia. I feel like I've heard of Julia. Is that an editor specifically? Yeah. It's an IDE for Julia. Julia is a language. Yeah. I think. Gonna interview with a company on Tuesday, so grinding leak code and performance optimization in Julia. Well, cool. I hope it goes well. Good luck. Oh, no, I know Julia. Okay, yeah, sorry. Long night. Yeah, good luck with that. I hope it goes well. And thanks for following. I plan on continuing to stream this project for as long as I am excited about it. So, as soon as I'm done with this metaprogramming, like the parser side, I'm going to actually go like building a platform layer and starting to build up like a core library and game engine and stuff. So, I appreciate the interest. Okay, so all of this stuff where we add nodes to the program, who all calls that? Do any of the metaprograms call it? Yes. Which I guess makes sense because you want to be able to, when you're manipulating their actual AST, you want to be able to Or, well, this same thing could be accomplished by just doing it in strings. Isn't Lisp the god of metaprogramming? I think that's relevant only due to Emacs being in Lisp. Yeah, I really dislike Lisp's syntax. It was definitely like early on, like the big metaprogramming thing. But I guess just to give you a brief overview of this, so this language that I'm making here, you're basically writing code that basically looks like C, but you can do stuff like I said, you can, snippets are basically macros, but you can have like templated, like parameterized structs that you can pass arguments to. So like you can pass it a type to use for an array that's inside of it. You can have parameterized types on function parameters. So like this function can take any type, right? And then when you call it, it will go generate a version of that function that takes that type. You can have variable parameters and loop over them, stuff like that. So anyway, you're going to write in this, but the actual metaprograms that you write are still written in C. So when you go to build it, it will compile the metaprogram, run the metaprogram, which spits out a bunch of code, and then compiles that as your program. So any advice for me? I'm a graduate, summer 2026. Well, I don't have a ton of advice because I was already out of school before all of this AI, like just before all the AI craze stuff took off. So in regards to that stuff, I don't have a ton of advice for you, unfortunately. I think it's really good to be diving into that stuff. So I wish you luck. Definitely just the fact that you're even in this and you kind of are keeping up with, like you said, the prime intellect stuff, you're getting interviews, like yeah, just keep doing what you're doing. Hardware, CPU, languages considered, C++, 17 and 20, Fortran, okay. A lot of languages there. Compilers. Like this is your current grind for HPC. Out of those things, like, I mean, Rust and Python and stuff obviously are big. I don't think C is going to be going anywhere for a while for like the real nitty gritty stuff. So I think that's good to keep doing. I definitely, a lot of the profiling tools you mentioned, like Valgrind is obviously big. Insight is huge for NVIDIA stuff. I mean, yeah, it seems like you have a good handle on what you're doing. So, the specific schooling that I went for was definitely a lot. It didn't have any of the. I could have taken some neural network classes, but it was early on, and they were just kind of starting with it, so I never took any of that stuff. So, so I need to understand, like here, right? We're looking in the AST. We want to add a node. See, I don't know. We kind of want to do both, right? We want to be able to just have you do strings, but we also want you to be able to do what I'm doing here and just manhandle your own nodes and stick them onto the tree. Right? But to do that, what tree are you sticking them onto? So when we say add node to program, what is that? It's appending a child. But... oh, wait a minute. Add node to program. We're appending the child immediately, and then appending it here. Do I have two add node? So I think that was just wrong. This is just wrong. Okay, this is less of a problem than I thought it was. What you think about Rust? I kind of just mentioned it before. I don't really have too many opinions. I haven't really ever programmed in Rust. I say I haven't programmed in Rust. So, C is kind of my bread and butter. So, I do not have an informed opinion on Rust, so I can't really say that much. Welcome, by the way, Vincent. Okay, add node to program I think can just go away. Right? We can just make that go away. Which means this can just be create node. Yeah, we're just going to create a new node and then append it there. So when we say create node, we have two of them. One takes an arena, one takes the parser. Do we want metaprograms to have to think about the arenas? Like, kind of not really. I don't want them to have to pass arena everywhere when they want to create nodes and stuff. So maybe we make another one here that is create node, and it'll just be the type. And we have the final program, we have the final parser, so we can just say return create node final program arena. Like, we can do that. Which means anything that calls this final program, it'll be contained to this file. So that was kind of the whole reason I was reorging this stuff to begin with. So I think I'm okay with that. Yeah, so that's fine. And when we call create node copy, that's in here. That also takes an arena, which we don't have to. This will just be the final program arena once again. Well, isn't that the whole point of our Scratch arena, is to do this kind of stuff? But the Scratch arena goes away. So no, never mind. If you're creating a node copy, it's because you're going to do something with it. So it's not Scratch work. This is work that's going to go onto the tree. So that's fine. This is the macros in C++ project, right? Macros in C++ project. Given that I don't know... I'm going to say no, given that that doesn't sound familiar to me. If you want a deeper dive, I have a video linked in the description of this channel that you can look at, but just very briefly here. Like the really rich metaprogramming macros. So no, this is... you can watch that video later if you want, but just to give you a brief overview, this started as a project where I was making a C/C++ parser that would allow me to do metaprogramming. Like, where you're actually generating a tree and manipulating the tree. And once I had that working, I realized I could just add whatever I want to the parser. So I kind of started adding a bunch of stuff like parameterized types of any kind and variable parameters and parameterized structs, even stuff like that. So it has kind of ballooned into my own kind of mini C-like language that has a bunch of metaprogramming in it. And then you can write metaprograms themselves in C, and I just pass you the entire AST. You're just given the whole thing to do whatever you want with it. So, and then ultimately that's spit out as C code. At the end, it's spat out as this giant C file, and the C file is what gets compiled. And you can also see it generates these chunk files to help you see. So this code, for example, all this stuff was generated by the metaprogram. So I spit it out in like a human readable format too. And what's cool is this giant C file at the end, because I spit out those chunk files and stuff, and I have your actual source code, I can use these line directives, so you actually get perfectly fine error messages too. Like, this will point to the right places. Either in this chunk file, it'll point to the generated code that failed, or in files of my custom language here, it'll point to the right things. So what is the DX of using this thing? Just call Clang with a plugin. So, like I said, so because this is all written in C, you can't see it right now. You can see it in my video. You can't see it right now because I'm in the middle of a major reorganization of this. But when you call my build, it compiles the parser and your metaprograms, if you have any. So it compiles all those into an executable, just using Clang or GCC, whatever you have. It'll compile that into an executable. Then it runs that executable, which parses your code, runs metaprograms on it, and spits out that C file. Then, assuming there were no errors, my build script automatically then again runs the C compiler on that outputted thing, which gives you your final program executable. So it's like every time you build, it's what happens here, so here's an example of a metaprogram, right? Like generating those struct templates. I pass you the AST, and then I have these macros for each node of type in tree, and you can just search for whatever you want, right? Here's all the types you can search for. You can search for all the return statements and do something with it. You can search for all the function calls and add stuff to it. I would show you the tree right now, but because things aren't building, I can't actually show you the tree unless I have one from an earlier run. Do I have AST? Okay, so this is a tiny one, but here's, for example, when this is working, here's the tree that gets generated, right? You can just see it. It's the entire AST. Here's an include directive. Here's one of my snippets. Here's main with all the stuff in it. Can this be used to walk through function forward declarations? So here's another thing. Yes, because you would see them on the tree. You can just loop through all your decal functions, right? But something else that I do before I spit out that giant C file is I actually do a dependency map on the AST. So you don't have to worry about where stuff lives. It'll do a dependency map, and that final C file is spit out in such a way that your source files don't have to care about where things are. Things can be put in any order, and the dependency map will figure it out for you. This is sweet. It's open to the public. Well, first, thank you. It's not open to the public. I have no qualms with doing that eventually, but I've been working on this for about a year now, and it is still nowhere near ready to be used, but I definitely need this. Well, I appreciate that. I'm very excited about it, for one thing. So like, for example, these metaprograms, like I said, they're just C. So you just define a file. This is actually a bad example, but here's one, right? So like you just said, I want to embed a C library into my toy language, and manually creating the wrappers is painful. This is exactly what that is for. So I can't show it to you here. Again, that video in my description does this, but I have a function here, a meta program that generates 2 string functions for every type in your program. And then from that, so it basically gives you a string of every type in your program, including structs, because it can loop over the struct members and like do all that. And then I generate print functions, right? I generate print functions that take a format string, and because I know that the metaprogram is generating 2 strings for all your structs, you can print out, you basically never have to write a print function ever again, right? It'll generate those for you. And because the metaprogram knows what types are in your program, the syntax is literally like, I'm writing in chat here just real quick. Right? You don't have to specify, like, it's just a %sign, right? If you want to print something in your format string to represent an object, you just use a single %. You don't have to tell it what type it is. The metaprogram knows what your types are, so it just does all that logic for you. So, yeah, it's I show that off in that video if you're curious about watching it. The print function thing is useful for when you don't have a debugger. Dude, print debugging is highly underrated. This is what STD format wishes it could be. I mean, that's partly also why I want to do this, because something else about this is I'm not using any libraries. So this is about as from scratch as you can do it. So if you look at, like, I'm on Linux right now, so these are my includes for this entire parser. They're just system headers. They are just stuff for the POSIX API, right? I'm not really including anything else. So you can't see it right now because it's failing, but like this thing compiles in like seconds and runs super quickly. I have a bunch of like performance info too that, again, I can't show you because I'm in the middle of a refactor right now, so things are broken. But yeah, I only started streaming this like earlier this year, so dude, you got to put this up somewhere even in a broken state. Oh, trust me, it is definitely the more I do this, the more I realize how awesome it's gonna be. So I definitely want to get more eyeballs on it. So the world needs this. A lot of the metaprogramming stuff is actually inspired by Jonathan Blow's new language, JAI. I don't know if you've heard of that, but it's a whole new program. Yeah, like from scratch, super from scratch with a compiler. I'm still built on C here, so although because I am generating the tree, if I wanted to go down the route of spitting out my own compiled code, I probably could, but I currently don't have any real plans or need to do that. So yes, JAI is super nuts. Full-blown message pipeline during compilation. Yes, that. So as opposed to me doing that, my version of that is you write metaprograms that give you the whole AST, and you just loop over the AST, right? So for like that 2-string thing, I'm just looping over for every struct decal in your whole program, and then you do stuff with it, right? I'm generating like functions, and then you append it to the program, right? I thought I was clever when I made all my types to stringable in my toy language. I mean, dude, I have tried some of this meta stuff for the last 2 or 3 years, and it was slow. The first one was just some basic introspection, and then the next one let me actually generate some stuff, but none of it was doing this thing where I'm actually like generating a tree, like a full AST. That only came with this project, which I started. When did I start this? I always forget. Let's look at the first commit. October of last year is when I started this. So a little over a year. I didn't think it was going to take me this long, but I keep finding new fun things I want to add to it. So that tends to be how it goes. My ultimate goal will be to make like another game engine and software library to start making actual things with, but this thing is pretty cool with C, less so with C++, since you can augment a simple lang like C. Yeah, and these are CPP files, right? But this is pretty much pure C. The only things I'm using from C++ are function and operator overloading, just because I find those useful. And very, very basic use of constructor-destructor pairs. Very basic. There's no like dependencies or class hierarchies or anything like that. This is all pretty much pure C. So no templates as well. This is kind of replacing templates. So can you make it so every string literal becomes something special? Yeah, I mean, yeah, you can do like, again, because you have the full AST, you can totally just loop over, right? There are nodes on the tree for literals, right? You can loop over all your literals and do whatever you want with them. And in fact, it's not just about looping over them and generating new stuff. You have the literal tree. You can loop over to where all your string literals are and replace them with whatever you want. It's not just adding stuff to it. You can replace stuff. So, like, you can rip out a whole node of the tree and replace it with whatever you want. You can replace all your string literals with, I don't know, integers, whatever you want. You can. The world is your oyster. The tree is there to do with what you will. And you still get the advantage of using GCC and its optimizations. Yeah, so this final file that gets spit out, it just handed as one big source file to GCC, and it compiles really quickly, and you still get good error messages. It's been fun. This started out as, I didn't even know if this would work initially, and once I get this part working, I'm like, oh wow, there's something to this. So, and like I said, it always starts with compiling your metaprogram. And again, I show this off in that video too, but when I kick off my build, it compiles the metaprogram, runs the metaprogram, compiles your code, and that's it. So what was I going to say? It only compiles your metaprogram if I actually keep a hash of all of your metaprogram code, and if it hasn't changed, it doesn't recompile it. So typically you'll compile your metaprogram once in optimize mode, and then from there, every time you build it, just has to run it again. But if your metaprogram has changed or you're working on it, typically you'll put it in unoptimized mode so it compiles really quick. And then once you're happy with your metaprogram, you set it back to optimized mode. But J still has the upper hand. Debugging inside macros is possible in J. Yeah. So that's actually why, if you noticed these things here, I have these things called snippets, which basically replace macros in C. And the only real difference is, like, C macros are just textual replacements, right? It just, wherever you called it, it just takes that same text, replaces some things, and plops it in there. It's like a copy paste. These snippets are actual parsed code. It parses this into a syntax tree. It actually parses it. And then once it parses that, it's got one of these trees, right, as a parsed snippet, and then wherever the snippet call was, it swaps them out, right? So it pulls out the call and plugs in the parsed snippet tree. So they're a little bit better than macros in that this is parsed. This is actual parsed code right here, and it gives me good error messages with that too. So not quite as fancy as J's macros, but way better than C macros. I will say that much. So yeah. Honestly, I'm kind of glad you came in and started talking because my brain is kind of getting mushy. I just did a bunch of ripping stuff apart tonight, and come to think of it, I haven't released my toy language yet, so maybe I shouldn't be talking. Yeah, I definitely would not mind giving this out, but it's also something that, like, I have no interest in, like, maintaining it for people. This is definitely for, like, personal projects and stuff, but dude, I got so much stuff to do. Yeah. This was supposed to be relatively small and simple. I mean, not small, but it was like, I had this thing working like 6 to 8 months ago, and I just keep adding more stuff to it, so I did get my just-in-time working and running. Cool. I embed my little language into Nginx and have my blog running off of it. That is awesome. That's definitely like, I don't use it for anything right now, but I have a website that's just like statically hosted. And I actually generate my website through my old software library in C. So the website is generated statically from C. And I definitely plan to do that again once I have this stuff going, but it'll be a lot fancier. But that's awesome though. I find stuff like that super satisfying. So it's super sketchy. I'm using Rust to communicate with Nginx and then doing FFI stuff in Rust. Yep. Yeah, I find this kind of stuff super fun. So I wouldn't be doing it if I didn't. So yeah. Well, if you're interested in seeing where this goes, I'm definitely going to keep streaming. I've been streaming for like 6 months now, once this got to a point where I could actually show stuff off, so I appreciate the follow. And yeah, I'm definitely going to be doing more. Once I am done with this, what I've been doing lately is trying to, all of these loops that go over the AST, these are currently doing full tree walks, and it's gross, and it's slow. It's not that slow, but it's slower than it needs to be. So I've been gutting some stuff to add a cache, so this stuff is all cached, but it's required me pulling a lot of stuff apart. So that's what I've been doing right now and why it's still broken. So I did end up using an off-the-shelf garbage collector because I couldn't be asked. I assume GC, you mean garbage collector. I used Boem, which is pretty good, surprisingly. I don't know what Boem is. Boem. Okay. Oh, it's for C and C++. Interesting. Huh. Can't say I'm a huge fan of garbage collection, just for performance reasons. But it depends on your domain, like what you're using it for. So, it does make writing code a little bit easier for sure. So. But yeah, like I said, brain is kind of mush after doing everything I just did. We're back at the point where the only thing failing is the util file. Wait, 955. What else did I break? Wait, what? Add node to program in 955. What? There is no add node to program here. 955. Oh, I'm in the wrong file. That would help. I did go the route of all objects are heap allocated unless liveness allows them to stay on the stack. The goal of my little language is to somehow improve on Lua and its ease of embedding into other applications. Gotcha. Man, I started, I don't know if you're into games at all, but I literally started programming by making stuff in Gary's mod in Lua when I was like 13. Which was, oh god, that was 20 years ago. That's upsetting. Oh, that's upsetting. That was 20 years ago I started doing that. Jesus. What the hell? Okay, anyway. Add node to program. That doesn't exist anymore. So I used to run a dark RP server with fun stuff I made in Lua. That's cool. I love finding people who... The fact that you can even say, hey, I was on dark RP and I made stuff in Lua. That's awesome. Man, those were fun times. The same YouTube channel that I just linked you, or that I just showed you, where that video is, where is... All you have to do is go back a little ways on that YouTube channel and you'll see all my Gmod add-ons that I made and released to people. The one I'm known for best is probably the Pikmin mod. That was when I was really young, and I made a game mode called Ultimate Chimera Hunt, and then a like Little Big Planet logic system, which is honestly the thing I'm most proud of. But yeah, fun times. So I used to do crazy dark RP stuff before it got popular. Kind of a hipster myself. Sick. Always love to be able to say that. Okay, man. I am really close. I just have to, like... I've set the stage for cleaning up all this stuff, but man... The last 2 days of doing this and ripping things apart and trying to put them back together, especially tonight, I think has taken my brain for a loop. And it's late enough that I may call it here. I really appreciate the interest, though, and the follow. I will definitely keep... You will see more of me for sure, so... I added cool crafting abilities, balanced classes, innovated on the money printer meta. That's super cool. That's really awesome to hear. RP stuff in Gary's mod was always... I never found one that I eventually like really liked. I feel like none of them did exactly what I wanted them to do, but I always found the RP stuff really fun. So I used to RP in the specialists on Gold Source, if that tells you anything. So anyway, okay, I'm gonna push this stuff up and tackle the rest of this. Yeah, absolutely. Thanks for watching, everybody. I think I say this every Friday that I will stream more this weekend, then I end up not doing it, but I do plan on doing more this weekend. So, we shall see. But yeah, thanks for watching. Have a good night, or a good day if it's daytime for you. And yeah, I will catch you all later.